Hi guys, I guess we're ready to start. So if you have any questions, just write it to the chat and I'll answer it. So let's start with our first task. I'll give you some time to read it. So what you need to know here is the type of graph. This is the scatter plot. This is the box bar chart, yeah. And that's a histogram, and that's a pie chart. So what you need here to know is only that if you have two continuous variables to visualize, you just use scatter plot. And we have the same task in variant 2, and we also use here the scatter plot. It may be a little bit complicated, so if you haven't understand it, please write anything to the chat. I'll wait a minute if you have any questions, or if it's easy to understand. Also write it, please. Well, I guess there would be no questions. Well, let's take a look now at the task 2. You should choose here the wrong statement. Okay, Arina, I see it. Yes, so you should choose here the wrong statement. Let's take a look at the theoretical information you need to solve the task. So you should know what's the median. I guess you all know that. Yeah, so that's basically the middle value. Now let's take a look at this picture. We have two types of quantitative values, discrete and continuous. So with discrete numbers, you can count something like 2 pens, and continuous are used to show some statistics, like 1.5 people in average or something like that. That picture shows us the normal distribution. I guess you all should know it, so we won't stop on it. And the last picture shows us what the mode is. And it's basically the most popular value in our distribution. So here the mode will be just right there at the top. So let's get back to the task. And let's take a look at the statements. The variable can be continuous. Yes, that's true. Because we can see that we have values like 0.5, and that means that that variable isn't discrete, and it most probably will be continuous. Then the median of the variable is 0. So how can we find the median of the variable? It's just middle middle of our values. So here the median would be most probably 0.5 and surely not just 0. So that's our wrong statement, what we were looking for. So yes, but let's take a look at the other statements. A series of values of a variable contains at least one mode. That's also true because almost every distribution has a mode until it's until it's not the line. So here we can see one mode that's the most popular value in our distribution. So that's also true. And the fourth statement, the variable is most likely a mixture of distributions. How can we know that that's true? So we can take a look at the normal distribution, and we can take a look at what our histogram looks like. So it's like the mixture of two normal distributions. So that's also true. Then let's take a look at the second variant. So here you should select all the correct statements. You can take a look at the task. Okay, let's take a look at our statements. The median of the variable is greater than 10. So we can see that median here is just a little less than 7.5. It's somewhere here. So it's for sure not greater than 10. Then we have a series of values of a variable has no mod. That's also not true. There can be no mode in well, okay, we'll just talk about it. So I don't think we need to repeat it. That's also false. The mean value of a variable is a positive number. Yes, it's wait a bit. Yes. That's the correct statement. That's the only correct statement here. Why? We can see that our median is somewhere. Wait. That our mean value is somewhere here. So yes, and it's for sure positive. It's somewhere around 20. Then we get the highest value of a variable is a negative number. We can see that the highest value of a variable is for sure a positive number. It's 15 or something like that, just a little bit more. So yes, we've got only one right statement, and that's the third. Well, I'll wait for your questions, though, if you got any. If it's clear, also please write it. Well, okay, nice. So let's take a look at the next step. I won't read it, so I'll give you a minute to read it. Okay, so what you should know here, basically you don't even need to know what the logistic regression is, but okay, I've got something here. So logistic regression is an algorithm in machine learning that, well, um, it it divides our data into the two groups. So you have the example here. Yes, and it computes probabilities of something. So with that line, we can split our data into the two groups. Uh, so what we do in our task, we just put our data into that equation and compute it. So we just put it here like that. And that will be our z value. You can use Python to compute it, or Jupyter or something else. And that will be 131, I guess. I don't remember. But that's not important now. And you got that equation. It's used to compute the probability in logistic regression. So you just have calculated that z value, and you just put it here like that. And then that's our final probability. So here the answer would be 0 and 79. I'm sorry. So now let's take a look at the same task in the variant tool. What you do here is pretty much the same. You just put the 5 here, compute the value, then just put that value here, like we have done, and you will get the answer. So the answer would be here 0 and 73. Yes, so tell me, is it clear, or I should tell you something else?
Can you show the slide with the formula, please?
Mm-hmm. That?
Yeah.
Mm-hmm. I'll send you the presentation later. Do you have any questions?
No, thank you.
Mm-hmm. Okay, nice. So I guess we can step into the new task. And here we have the same information we need, like in the task 2. Yes. So about median, about continuous and discrete variables, about mode, about distributions. So I'll give you a bit time to read it. Okay, let's now read the statements. The median height of an adult man is 155. We can see that that's true. The median value is just here, so it's 155. No, less than 3% of adult men are less than 135 centimeters tall. So here is 135, and we want to calculate that part of the distribution. So we can see that that and that part give us 2.1%. So and 0 and 0.1%. So that that part of the chart plus that part of the chart will be 2.2% of our values. So these values would be just half of it. So so yes, less than 3% of adult men are less than 135 centimeters tall. That would be something like 1.1%. The next, the mode of growth of an adult man is 165. We can see that 165 is here, and that's not our mode for sure. Our mode will be here. So it will be 155, and it will be the same value as median. Now, so that's false. 34.1% of adult men are taller than 155 centimeters. So we can find the value 155, and I guess we can just say that the half of adult men are taller than 155. So that's also false. And here we have just basically the same task where you should select all true statements. So we can take a look now. That approximately 68.2% of adult Chow Chow dogs are between 49 and 53 centimeters tall. Wait a minute. Yeah, so let's take a look here is 49 and here is 53. So they want us to calculate that area, and it's obviously already calculated for us. So that's 34%, and that's also 34%. So it will be 68.2, and that's right. Yes, that statement is right. The mode of growth of adult Chow Chow dogs is 51 centimeters. Yep, it's also true. As we said earlier, the mode is here in that chart. Yeah, so that's also true. There is no adult Chow Chow dogs that is exactly 51 centimeters tall. We can say that that's wrong, and exactly 51 centimeters tall is the most popular value of the dog's height. So that's false. Less than 13% of adult Chow Chow dogs are less than 49 centimeters tall. 49 is here, and yes, and that part of our what's the first statement from? Well, I just lied a little bit to you in our last task because I thought that 34% is the sum of these areas. So basically it's 34% in that area and 34% in that area. So so have I made it clear now? I just
No, because it shows
Mhm.
that the color green is equal to 34%. Why is it partly?
Can you repeat it?
It shows on the graph that green color is equal to 34%. Why is it
Yes.
compared to the half of it equal?
So that colors show us just the half of it. Because you can check that. So you can just sum all these values and it should give you 100%.
Oh,
And some of these values will give you just 50%.
Okay.
So could you repeat about the mode once again? Was it false? The mode, you mean that statement? I said that that is not false. I said that that's true. Or maybe I said that it's false. But okay, that statement is true because our mode is here, and that's 51 centimeters. Is it clear now?
Yes, you just did say that it was false. That's
Oh,
why.
okay. I'm sorry.
It's
It's my
fine.
mistake. Okay, so is it clear now with this task?
Yes.
Okay. So what's that task? Okay. I'll give you a minute to read it also. Yes, so that task is about representativeness of samples. So let's take a look at this slide. And it basically says that the more diverse data we collect, the more representative sample would be. So we can see this picture that when we got here, two people from the same group and two people from the another group, that would be worse than if we got one human just from every group. So is that clear about that? Okay, let's take a look at the task. So here we got a few statements. Data on iris flowers collected in arid regions. It would not be much representative because we won't have data collected in non-arid regions. Yeah, so I guess we should find something more representative. Data on iris flowers collected from 4 greenhouses in the city of Cameroon. That would be the least representative statement because it doesn't show us much about iris flowers in the whole world. It just shows us the information about it in Cameroon. Next, we got iris flowers data collected at random points around the globe. And I guess that would be, well, okay, it's the correct answer for sure, because it will be just like here. So imagine that there are people from all around the world, and it's better for us just to take one human from each point on the globe. And we also got data on iris flower collected in a separate field. That would be also not representative. I guess it will be less representative than camera statement. I'm sorry. Yes. So the answer would be here, that third statement. Let's take a look now at the second variant task. But the task here is which of the samples he collected would be less representative than the others. So here we can take a look at the statements. Coral polyp data collected during the winter season. It's not representative at all. Then we got from random locations around the globe, and that's as in first variant, that's most representative way to collect data. On random days of each month, that's pretty representative too, but not like the second. And we need the least representative statement way of collecting the data. And here we got inhabited with a significant diversity of these species. So that's pretty much representative too. Yes, but our task isn't, sorry, isn't to find the most representative statement samples. So obviously the answer here would be our first statement because it's least representative for us. I guess that should be clear for you. I'll wait a minute for your questions. Well, I guess Arina's answer is enough to continue. So now let's take a look at the task 6, and I'll drink some water. So what we've got here is speaking about correlation. Let's take a look at that slide. And the correlation is basically the mirror that describes how one variable relates to another. So if GDP and IIP have correlation 0.42, that means that that one value depends on another a bit. We can make a scatter plot like here. I'm sorry, wait a moment. Yeah, so if we have correlation, our values will be aligned like that or like that, or the correlation can be low. And when we got 0.42, that means that it's weak, but it's existing. So yes, and our correlation is positive. So like it says here, if one variable increases, then the other tends to increase too. So let's take a look at our statements. If the IIP increases with other things being equal, there will be an increase in GDP. Yes, that's true because as we talked earlier, we have positive. When our correlation is negative, we would have a minus here. Yes, so if one value increases, the other one will be increasing too. So that's true. Let's take a look at the second statement. GDP and IIP are related only by a linear relationship. Let me think about it a bit. Well, their relationship is not linear, so it's something like that. So I guess we can say that their relationship is linear. Their relationship is linear when there is something just like that, and we got that because we got low value of correlation. Then we got the sample correlation coefficient between the IIP and GDP is also 0.42, and that's basically the same as we got here. So they just replaced GDP and IIP, and that doesn't change anything. So that's also a true statement. And the last statement, GDP and IIP are independent variables. That's not true because independent variables would have a correlation near zero. So now let's take a look at the second task. I mean, the task in the second variant. So it's basically pretty much the same. Let's read our statements. And there is a strong nonlinear relationship between KM and PM variables. And that's not true because that not nonlinear relationship would be something like that as we had in our previous task. And we have here almost correlation that is almost 1, and that's very high value. So our values are something like that. And then we got here, yes, and statement A is false. So statement B, as we can see, is true because, as I said earlier, our relationship between our two values is something like that. I'm sorry, I'm just a bit ill. So that statement is true. Let's take a look at the third statement. An increase in the number of new customers per month causes an increase in the company's monthly advertising spending. Um, Let me think a bit. Well, I'm not sure about that statement. It looks it looks like true because we have strong correlation, and as we said earlier, if one variable increases, the other tends to increase too. Someone has mic on.
Excuse
That
me.
may
Here is
be.
written that one variable causes an increase in another variable. But
Can you repeat it?
here is written that one variable causes an increase in another variable.
Yeah. Yes. And
Correlation
what's the question?
show causality. It shows relation between variables. Can we say that one variable causes an increase in another? Isn't it like if one increase?
Yes. We can say that if our correlation is positive. So.
But it's not. It doesn't cause. It's just the rule that if it's positive,
well, yes.
proportionally, but it doesn't mean that exactly increase in the number of new customers causes an increase in the company's monthly advertising. We don't know what.
Yes. Okay. So the other tends to increase, but it's not always. It's not the rule. That's what you wanted to say. Yes.
I want to say that is it like appropriate to say that it causes? It can be not a right option, but like it wants to catch us on this moment.
Yeah. So I haven't even looked at the task before, so I see it first time now. But I can tell you that these two statements are wrong. And I guess so. That's not the rule here. That's just something that might be. But okay, I'll take a look at the task later, and I will. There can be another variable, for example, that. Yes, you're right, but we have here only two variables in our task. Okay, I'll show you I'll send you the solution to that task after that consultation. I just need a little bit more time, and I'll also send you the explanation. Okay, the correlation is not about causes. Yes, it's not about causes, but it shows us how one value relates to another. So if we'll get some value that will be high in that x, so it most likely will be somewhere here. So that x will be high too. And if we increase that value up here, it will be somewhere here. Well, it's pretty much complicated to explain now, and I guess let's take a look at the next task, because I need to make sure that I'm not telling you the wrong thing, and I'll better send you the explanation where it will be clear for everyone. Is it okay? Artyom, is it okay for you?
Yeah, thank you.
Okay, nice. So let's take a look now at the KNN algorithm task. Do you know what's that algorithm and what it does? I'm waiting just yes or no from you.
Can use numbers, it means.
Okay. So the KNN algorithm is k nearest neighbors algorithm. So if we have some pieces of data and we can make a scatter plot, like in first task, so that algorithm just splits our data into the few groups. So like in the picture, and we got parameter k here, which shows us so the algorithm picks the point somewhere in the middle of the group, and k nearest neighbors will be that group. So here k is the parameter that is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So there is 9 pieces in each class. Yeah, so let's take a look now at the second picture, and we basically can say that Euclidean distance is just distance between any 2 points, and you have formula here, but I guess you don't need it for the task. So let's take a look at the task now again, and we should find which group, which class belongs our red star. And it will be just basically the closest value. And we've got k equal to 1 here. So it will belong to the class of that square, and that's class 3, and the correct answer would be class 3. Let's take a look now at the same task from the second variant, and here we got red star here between 2 dots. I'm sorry again. Yes, so we will have 2 nearest neighbors, and our red star will belong to the class which these 2 dots have, and that's class 1. So the answer here will be class 1. Is that task clear for you? Mm-hmm. Anastasia, okay, maybe Artyom. Okay, I guess it's clear. Well, here we got the task on the same topic as, I don't remember what task it was. It was 4 and I think task 2. So let's take a look at the statements. Well, okay, the question here is which variables might correspond to the bar chart shown in the figure below. We've got the amount of water per person drinks per day, and it's not because we can have 1.5 liter that person drinks, so that's not our case. Next, and also we can have more liters, like 7, 8, 8.5, and it should not be that little amount of our values. Next, we got the result of a single toss of a dice, and that looks like a true for me because we got 6 values on a dice. Yes, and that corresponds to our values. Next, we got the result of a single coin flip, and that's not the case here because what can it mean in a single coin flip? So it just false. The number of buildings built in Moscow from 2005 and 2015. That also can be true because I guess the number of buildings built in Moscow in that amount of time will be much more higher. So the answer here would be will be a single toss of a dice. And what we got in the second variant, I haven't seen it too. Okay, let's take a look at it together. The number of liters of water that an adult person drinks per day. Yes, that can be true, but I guess that's also not the case here. But no, it may be true. Let's yes, that may be the true statement. The second is the proportion of customers of a known phone brand who are satisfied with the purchase. So here, the most popular value is 2.5. So there can be such a proportion. Well, imagine, can I write here on the board? Sorry, wait a bit. Yeah, so if we got, for example, the amount of customers, for example, we have 100. I'm sorry for that, but so our proportion can be just bigger than 1, because we can have, for example, wait a minute, 2,500 people that were satisfied with the purchase out of 100. So it can be more than 100. So the value of that proportion would be always from 0 to 1. Yes, so that's also false. Then we got the number of people participating in the Moscow Marathon. Well, we can't have 2.5 people. That's a discrete value. Then we have the number of birds live in Moscow for the winter. That's the same case as here, because we can have 2.5 birds. So obviously the right answer here is that first value. Oh, statement. Sorry. Okay, so is this task clear? Task 8. Anastasia, I'm waiting just for you. Okay, nice. Oh, an arena. Nice. Okay, what we've got here. So you just need to pick the given the values from the list. So you got you need to select where is mode, where is median, and where is mean on that graph. So we can say that the mode is here because it's the most popular value and it's somewhere around 2. So we can pick that green is our mode. Then we need to take a look and select which one is mean and which one is the median. So our median is most probably here because it's well, I would say that our median is somewhere here, but yes, let's say that it's here. So the blue line would be showing us the mean value in that sample. Let me check it if I haven't lied to you. Yeah, that's true. So we got here the same task. So obviously the mode here will be that green line. Our median will be that blue line. Let me also recheck that. No, that blue line will show us the mean value. Yes, so it's somewhere in the middle here, between that and that. Yes, so our red line will be our median. I guess it should be pretty clear. Well, I should have had a different explanation for that task. I think I'll send you the solution and explanation also later to the channel. I'll add it to the presentation, and after that it will be in channel because I really messed up and haven't showed you what the definition of the density function is, and it's pretty much important for the task. Okay, so let's take a look at our last task. Yes, so I need to know if you know what if you remember what t-test is and how do we test our hypothesis. I need just yes or no from one person.
Well, you would have to divide the estimated coefficient by standard error, which is, as far as I remember, the standard deviation divided by the number of observations.
Yes. Okay. So let's let's start from the beginning. So we got some hypotheses that we want to check. For example, we've got here the estimate of the coefficient W, and we want to check our hypothesis that it's equal to 0. And how do we do that? I mean, you just put the numbers in Python formula and it makes everything clear. So we have to calculate the t statistics, and in our case, that will be that value of coefficient estimate, that is 13.2, and we just divide it by standard deviation. So we get our t statistic that happens in that line. And also we calculate the number of our degrees of freedom. Yes, and that would be, wait a moment, I just feel like that's a little bit incorrect. Well, okay, I guess that's not correct, but that doesn't have impact on the answer. So the number degrees of freedom is just the number of our observations, which is 17, minus 1. So that will be 16, not 15, like it's here. Yes, and then we just use the Python function. Does everyone have a Python course? Okay, just you may just I guess I don't need to explain it for you from the beginning. Yes, so you have a function that calculates critical values for you. So you just put in that function 1 minus our 5% divided in half, because we test our two-tailed hypothesis. And we just use the same degrees of freedom as we wrote here, but there should be one. Yes, so that's our ways how we can calculate 5% significance level test and 10%. Yes, and if we just write these values, our t statistics will be 3.3. Our p-value would be still like something like 2%, and if we check our 10% hypothesis, that will be lower than 2%. So let's take a look now at the statements. And I'll remind you that if we have, for example, 5% significance level hypothesis, so if our p-value will be less than 5%, then we deny we reject main hypothesis and accept alternative. Yes, so as we have calculated here, these 2%, it's less than 5%. So we can just reject our null hypothesis. Yes, so the answer here is the main hypothesis is rejected at the 5% significance level. And we got that that statement it's not true, and that statement also is not true because we got p-values like that. So for that task, you should calculate it. Well, that might sound pretty much complicated, but that's what it is, and I guess I'm not the best person to tell you it from the very beginning. But as your professor said to me, you have studied the topic.
Excuse me, could you tell me,
Yes.
please?
Mhm.
Do you know, is it possible to use our
What?
previous notebooks during the exam?
Well,
Because it takes
I
time to
guess
write down these
Mhm.
codes, and if you spend so much time on just the task from
I
the A part,
I think that you won't be able to do that. I know that you can use your there is some шпаргалка that you might use. Maybe it's in Smart LMS. But I think you should ask that your professor, or you can write email to the center that does these independent exams. I'm just not from there. Is it okay? My answer?
okay.
Yes. So yes, we got. I have that picture for you, that shows us why we divide that value in half. So we want to find that or that value, and yes, so we divide alpha into 2. But as I said earlier, you just use Python and calculate statistics. Can we use R instead of Python? I guess that you can. Yes, I think yes, but I'm not specialist in R, and I guess you should better ask it to someone more connected to the exam. Yes, so we got the same task in the second variant here. And here we don't even need to calculate anything because it's written here that it turns out that the p-value for this test is 0. So it's less than 5%, and then we reject our hypothesis. So all other statement say that we do not reject it, but we should. So yes, I guess that will be all for today. We don't have much time left. Well, you can ask me some questions now if you have anything to ask. I'll give you 5 minutes, and then we'll just end that consultation. Thank you, guys. Thank you. Thank you. Goodbye. Then I guess no one has any questions. So have a great evening too. Goodbye.